Welcome to the guided practice for Unit 3. Let's go ahead and start talking about the academic vocabulary that you need to memorize for your retest. The first term on there is proton. Proton is a positively charged particle. It's located inside the nucleus. A neutron is the same mass as a proton, but it does not have a charge. It is neutral, and it's also located inside the nucleus. And then we have the electron. The electron has a very small, insignificant mass. It's located around the nucleus in the electron cloud, and it has a negatively charged particle. The next term is electron affinity. Electron affinity is the ability for an element to pull electrons toward itself. It's the ability to remove an electron from another atom. Ionization energy is the amount of energy required to remove an electron from an atom. An atomic radius is the size of the atom. And then electronegativity is the pull of an atom on the electron in a chemical bond. Next, we're going to look at 4 scientists and talk about their contribution to science, specifically to the model of the atom. John Dalton is the father of the atomic theory. He first proposed and empirically tested evidence for an atom. J.J. Thomson was responsible for the discovery of the electron. Ernest Rutherford, with his Rutherford gold experiment, experimentally determined the nucleus. And then Niels Bohr was responsible for quantized energy levels. So there's the energy levels around the nucleus of an atom. So jumping into some questions, the first one is talking about the model of the atom. And it says rank the models of the atom from least accurate to most accurate. And so what we would do is we would just list them in scientific order, starting just with our scientist. And so John Dalton's would be the least accurate. And then we have J.J. Thomson would be the next. And then we have Ernest Rutherford. And then we would have Niels Bohr would be the most accurate representation. The next one is between each model describe the experiment. And so when we are looking at Dalton's experiment was dealing with different gas molecules and dealing with gases to experimentally determine the atom. And then J.J. Thomson was using cathode ray tubes to experimentally test to find the electron. And then when we have Ernest Rutherford, Rutherford gold experiment, and he shot alpha particles at gold to determine that there was a nucleus. The next question, it says between each model describe the new knowledge gained from the experiment. And so with Dalton, we determined that there was an atom. With J.J. Thomson, we discovered that there was positive and negatively charged particles. With Ernest Rutherford, we determined that there was a nucleus. Moving on to protons, neutrons, and electrons, describe the effect of each on an atom. An electron. Electrons, when we add or remove electrons, we give them their charge. And so if we have the same number of protons and electrons, we have a neutral charge. But if we add or remove electrons, we change the charge. Neutrons. When we add neutrons, all we do is add mass. So it changes the mass of an atom. And then a proton. When we add or remove a proton, we are changing what the substance actually is. And so when we add or remove, we are changing what the element's identity is. The next one we're looking at, we see it says determine the number of protons, neutrons, and electrons in the following. So when we're looking at this, all we're seeing in our first one is we just have krypton. Krypton is 36 on the periodic table, and so it has 36 protons, 36 electrons. Since it doesn't give us a specific isotope, we could look at the atomic mass and just subtract 36 from the atomic mass, and that would give us the number of neutrons. When we look over here, we see we have nuclear symbol notation, and so therefore we can just go ahead and subtract those things. Fluorine, we know that fluorine is going to have 9 protons, and we see that it has a negative charge, so that means it has one more electron than it does protons, so it has 10 of those electrons and only 9 protons. When we're looking at nuclear symbol notation, we'll take hydrogen here. When we're looking at this one, we see that we have 3 protons, we have a mass number of 3 up here. We have 1 proton. So when we're looking at it, all we have is, if we subtract 3 minus 1, we see we have 2. So what we will have is we'll have 2 neutrons. And then that means that we will have 1 proton. And since it is a positive charge, that means that we have 1 more proton than we do electrons, and so that means we have 0 electrons. And we'll go ahead and leave C for you to do. Try to do the same thing that I did, but just look and see that it does not have a charge, so the number of electrons and protons are going to be equal to each other. So see if you can't find the protons, neutrons, and electrons in that one. When we're talking about ionization, ionization is when we have a removal or addition of an electron. It says, what is the difference between an ion and an isotope? An ion has different number of protons and electrons. An isotope is just a same element, but it has a different mass. And so it has a different number of neutrons. So ion, different number of electrons. Isotope, different number of neutrons. Number 7, how can you ionize a substance in a laboratory setting? If we add electricity to it, we can ionize it. We can put it in any type of salt solution. When it goes in a chemical bond with a ion or with a metal and a non-metal, when you put them in solution, they'll ionize, and you can actually use a battery and pull all the negatively charged particles to one side. 8 says, write the ionic notation for the following. So we have 3 protons, 2 electrons. 3 protons tell us that it is indeed lithium. So it is lithium. And we see that we have 3 protons. And we have, doesn't tell us the number of neutrons, but we can write lithium. We really don't have to write the 3 right there. But what we do to find the charge is we go protons minus electrons. So 3 minus 2 is going to give us plus 1. On the next one, we have 9 protons, 10 electrons. So 9 protons tell us that it's fluorine. And then all we do is 9 minus 10 is going to give us -1. And then 11 protons tell us that we have sodium. And we have 11 minus 10, which is plus 1. On our next one, it says calculate the average atomic mass or percent abundance of the following. What is the average atomic mass of an unknown element that has 2 isotopes? The first isotope is X29. It's just a made up. It has abundance of 14%, while the second is X33. It has abundance of 86%. So all we do here is we take the mass, which is 29, and multiply it by the percent. Now the trick with the percent, make sure you put it in decimal form. So we move the decimal 2 places, so it's 0.14, and we add that to 33 times, move the decimal 2, 0.86. And we go ahead and multiply those out, and we should get a mass around 32.44, and that would be our average atomic mass. On the next one, it says chlorine has 2 isotopes, chlorine 35 and chlorine 37. The possible percent abundance for the isotopes are 24 and 76. The average atomic mass of chlorine is 35.5. What is the percent abundance of chlorine 35? And so when we're looking at this, if we look and we see, well, the average atomic mass is really close to 35, so therefore the higher percentage will go with chlorine 35. So the answer should be 76%. And then lastly on C, Let's go ahead, and the only trick to this one, we can plug in the numbers here. But when you get your mass, it says identify the unknown element. So all we have to do, find the average atomic mass, and then look on the periodic table. Now you do the math, and you should hopefully come up and find that it is bromine. Now looking at the periodic families, it says use the periodic table to answer the questions below. Name the families on the top of the periodic table. So we have our alkali metals, and then we have our alkali earth metals, and then we have our transition metals. And then the really big ones, remember that we can say that whatever the element, so whatever element is on top, that could be like the oxygen family or so on, but really the only nonmetals we're really concerned with are the next one would be we already used that color, the halogens, and then we would say the noble gases. And then on the bottom of the periodic table, we do have our lanthanides and our actinides down here. So on B it says what is the charge of each family. This is really important to learn, memorize, because we'll use it a lot later on. So this is +1, +2, skip all the way over. This is +3, and then plus or minus 4, and then -3, -2, -1. And then the noble gases have an overall charge of just 0. And lastly, it says list the properties of each chemical family. So go ahead and go back in your notes and look for each specific family, the alkaline earth, transition, halogens, noble gases. Look for each one of those and write down their chemical properties.